Hey guys, in this example we're going to find the key features of the function and then sketch. So since this is a rational function, the easiest way to identify the important features is to have it factored. So the first thing I'm going to do is factor out a 2 GCF on my numerator. That leaves x squared minus 6x plus 8. And then on my denominator, it's still x squared minus x minus 12. So both of these now can be factored using Xbox. So my first one multiplies to make 8, adds to make negative 6. It's negative 4 and negative 2. If I draw my box, x squared minus 4x minus 2x plus 8, factor out an x. Fill the rest for multiplication. The next one, it's multiplying to make negative 12 and adding to make negative 1. That's negative 4 and 3. X squared minus 4x plus 3x minus 12, factor out an x. Build the rest with multiplication. So now my function is 2x minus 2x minus 4 over x plus 3x minus 4. So in this problem, we need to find asymptotes, intercepts, and holes if they exist. So the first thing I'm going to look for is my vertical asymptote. That's when my denominator equals 0. That means x equals negative 3 or x equals 4. For my horizontal asymptote, since the degree of my numerator is equal to the degree of my denominator, y equals 2 over 1 or y equals 2 is my horizontal asymptote. Now remember, whenever you see a common factor that will cancel out, that helps you figure out your hole. And your hole happens when x minus 4 equals 0. So at x equals 4 is going to be a hole in your graph. So the other part of the problem we need is our y-intercept. That's when x equals 0. If I plug in 0 into these x's, I'm left with y equals 16 over negative 12, or negative 4/3. So that is my y-intercept. And my x-intercept is when y equals 0. And that happens when my numerator equals 0. So 2 times x minus 2 times x minus 4 equals 0. X equals 2 or x equals 4. So we've got all of our important pieces here now. In the next video, we'll sketch.